Okay, so we had the cubic one from yesterday. Then, question 4A, which is on page 418, okay, is going to be based off of that model. Okay, so it says, downtown is congested when more than 20,000 cars are on the streets and highways. Predict when the downtown will be congested. Explain your reasoning. Okay, well, 20,000 on our graph. That's a good one. That's a good one. And let's go with blue. 20,000 would be right through there, correct? Okay. Because each one is going up by 2. So, what do I want to look at in terms of 20,000? When is it going to be, when is downtown congested? Above 20,000. So I want to know, when is it congested? Well, let's take a peek here now. Let's look. So when do you think downtown is congested? $3:50 to 6? 3:50 p.m. to 6 o'clock, because it's a little bit before 4, right? Because this right here is 4. So 3:50, 3:45 or somewhere in that range. Okay. All right. I would concur. And would we say 6 o'clock? Okay. Predict when it's less than 10,000. Anybody got a prediction for less than 10,000? Noon to 1:45-ish. I gotta make this be a little. So what are we looking at? So up here we were looking at above the blue line, right? Bless you. But down here now we're looking at what? Below the green. Okay. So let's look. Let's drop it like it's hot. Drop it like it's hot. Drop it like it's hot. Okay. So what was your prediction here? I'm sorry.
I said like noon to 1:45-ish.
Noon to 1:45-ish. Does anybody agree with noon? Why did you pick noon? Hmm? Okay. So, okay, all right, because the 0 would be the 0 would be kind of back in here, right? And this is going to continue going up. So maybe even a little bit before noon, right? Maybe like let's say 11:30-ish. Okay, we can extrapolate back, sure. So 11:30 a.m. to, what did you say?
Probably like 150.
150-ish? Just start over. And then what did you say, Max?
Well, like graphically speaking, 7 o'clock to infinity, but like 7 o'clock to...
So could we just say after 7?
Yeah.
I like that. Okay. How am I going to predict the number of vehicles that enter or exit downtown at noon? How can I predict that?
Well, I mean, it shows that at like 12:30, 1 o'clock, that the line is like, it was like going up before that. So
It says when it's congested, there are more than 20,000 cars. So you could take the top point and for the highest point on the graph there, it says it's 20,000 and then divide it down as you go down the graph.
Okay. And so then how can I predict when there's cars at, or the amount of cars at noon? Because are you saying, Austin, are you saying that this right here is noon?
No.
Okay. Good. That's a good thing. It's tough, right? Okay. Plug 0 in where? I could plug 0 into my function. Why 0?
because that's supposed to be 12.
Because what did we start? What was number 1, or what was x equals 1? 1 o'clock p.m. Right? So noon would be our 0. Okay. So one way is I can say that noon is our 0. And I can put 0, I can find the value of the function at 0. Right? So I could put, I could read off what my regression equation is off of my calculator, or I could do this. I'm going to show you this one. Okay? So there is my function. I'm going to start a new page. And my new page is going to be a calculator. Okay? Probably want to follow along with this because this is going to make your life easier as you go through the rest of this chapter. Okay? So I'm going to start a new page. And I'm going to get my cubic regression on this calculator. So I'm going to go Menu, Statistics, Stat Calculations, Cubic Regression. I'm making the cubic regression in my calculator like I had done yesterday. Now for me, the X list was time, the Y list was vehicle. So I went T and V for those. It's however you made it today, whatever you labeled your columns as, that's what it is. And now what's going to happen here is it's going to put my function into f sub 2. Okay? It's going to take this cubic function. Yours is probably going to go into f sub 1. Okay? But wherever this says right in here, that's where it's going to dump that function. So mine is being dumped into f sub 2. Okay? So all I have to do now is type in f sub 2 of 0. And when I hit enter, it will give me the value of my function. Because this is bold here, that tells me that it's a defined function on my calculator, and it gives me the value at 0. Oh, come on. Why are you being goofy? Now where did you go? What? Why is it being goofy? Come with me. It's all over the place. You can't get a hold of it. Now there's like, what?
This is like perks and benefits.
What?
And, perks and benefits and the Promethean. Oh.
Got like 1,000 of them in there. What the heck? Alright, well, we're going to start deleting these.
There's a lot of deletion.
Hold on, we're going to have to pause. Alright, technical issue solved. So then we said this was back. I got to fix this up here now again. This was to about 150. And after that. Okay, so this is saying that now f of 0 is equal to 8.4429, we'll say. Yes? So how many cars are going in and out of downtown at noon?
80,000 or 84,000. No, 8,000.
8,000. 8,440. 8,443 vehicles? Why 8,443 vehicles?
Well, you can't drive 9/10 of a car.
Okay, that's one reason why we have to round up. Can't drive a part of a vehicle. But why is it not 8 vehicles?
Because it's in the thousand unit is about.
Because our unit way back here on our chart here, it said that we were in thousands. Okay, so that's why we have to multiply there by 1,000. Okay. So now, since you all have that on your calculator, predict the number of vehicles that enter or exit downtown during the hour starting at 9 p.m. What's the value that I'm going to place into my function? 9. So I'm going to find f sub 2 of 9. and I get negative 43.75.
43,000
No,
Means cubic
Oh,
is
didn't
very.
don't you subtract it from the 1,000?
no.
Cubic is an extra.
So how many cars are going in and out of downtown at 9 p.m.?
Negative 43.7.
Would you subtract it?
Negative 43?
Or negative 4,375.
Negative 43,750 vehicles.
Is that less than?
Does that make sense?
Would it be 800, 8,000 minus that?
Nope.
Talking about like the previous site.
Why doesn't that make sense?
Yeah, why would 43,000?
You can't have negative vehicles, right? Okay? So does our model work at 9 p.m.? No. Let's go back to the picture of our model. When would our model stop working?
7:30.
Right at about 7, just a little, actually at 7:30-ish is when our model would stop working. Okay? Because then we go into negative, and you can't have negative vehicles driving on the road.
Why is that?
Why can't you have negative
Well,
vehicles?
No, I get that. But
Okay.
like, why would the graph go negative?
Because it's a cubic function.
Okay.
Okay? And so it's going to keep going down and down and down. Yep.
What if we use like the, what is it, like the swap?
Sinusoidal?
Sinusoidal, yeah.
Okay? Then it wouldn't.
Yeah.
Yeah. Then it would just be a sinusoidal one's a wave. Yeah. Okay? So, predict the number of cars that enter or exit downtown starting at midnight. Negative 12 is the value that we're looking for here. So we would need to find f sub 2 of negative 12. So I get 1,267.23. Right? But then that's got to be multiplied by 1,000. So that's 1,267,000.
230.
Yep, it is 2. Whoop, this one. Come on now. Got my 2 there. Does that make sense? That at midnight we have 1 million vehicles on the road.
That's it,
Yes.
like a random midnight biker.
Exactly. Exactly. There's some massive party going on. Big rager going on downtown. Okay? All right? So, question number 5 now. Consider the data and our regression equation. For what intervals does this model work? Let me put the model back on here again. For what intervals does this model work? It works at noon, right? So maybe noonish to 7 to 7:30?
I think 11 would work.
11 you think would still work? 11 a.m.? Okay, all right, I'll go with it.
It's a little.
Otherwise, it doesn't work, right? Doesn't work after 7:30 because we can't have negative vehicles on the road. And it doesn't work before 11 because you get these huge numbers of vehicles on the road. Okay? So, part B then says, sketch a curve that you believe accurately predicts the number of vehicles on the road over a 2-day period. Okay? So, at noon, there should be vehicles on the road, right? Okay? Probably a fairly good amount, right? What did we say at noon was? Yeah, but what did we
8,000.
8,000?
Yep.
Okay? So, we're somewhere over in here, right? And then we went up. No, we came down a little bit. But then we went back up. And then we came back down. And we probably went back up. Back down. Back up. Back down. Right? Something like that. Depending on what's all going on in town that day. Okay. And we talked about that yesterday too. We added that in yesterday too. So, okay. And that, as Austin said, that's a sinusoidal curve. But that's pre-calc. Don't worry about that. Okay? Alright? Tomorrow, you've got green and yellow, both due. Okay? Tomorrow. And then we'll continue on. Actually, I think we're done now with 5.2. I think we go to 5.3 tomorrow. Okay?